Hello everyone, in this video we are going to talk about how to name aldehyde and ketones. So when we talk about aldehyde first, it is a carbonyl group. We are going to have a carbon-oxygen double bond. So on this sp2 carbon, on one side you can have an alkyl group or a hydrogen. On the other side you will have a hydrogen. So that gives us this functional group, which is the aldehyde group. And if you write it in short as condensed formula is CHO. So that is our aldehyde. And for the ketone, we also will have a carbon-oxygen double bond because it's one of the carbonyl compound. And on both sides of this sp2 carbon, you will have R group. So this R group can be the same, can be different, can be sp3 carbon or sp2 carbon as well. So that is all our ketones. So first, we are going to look at how we can name them in the IU pack system. For example, if we have this aldehyde right here, for aldehydes, this is an acyclic aldehyde. Your R group is an acyclic alkyl group. So what we are going to do here is we are going to number the parent chain first. So parent chain, the carbon of the aldehyde functional group will always get as number 1. So we'll have 1, 2, 3, 4. So if you recall, if we have 4 carbon, we will have built as the indication, the prefix to indicate there are 4 carbons. And if you have a 4 carbon alkane, that is C4, hydrogen 10, 1, 2, 3, 4, that we'll call butane. Now what we are going to do is we are going to drop off this E and replace by Al to give the aldehyde naming. So what does that mean? For the one that we have here with 4 carbons, we will call it butanol. So the Al at the end will tell you that the parent chain that we are looking at here is a aldehyde. So that is when the R group is an acyclic substituent. So what if we have the aldehyde group on a cyclic substituent? So since aldehyde still is our functional group, we will indicate that's still a aldehyde. So for this aldehyde, first of all, we are going to call out what is a substituent. So for this substituent, we have cyclohexane. We'll show that cyclohexane. And then what we have here is aldehyde is called carboaldehyde. So we'll basically give the name carboaldehyde to show that we have a aldehyde functional group that is on the cyclohexane. So the carbon on cyclohexane which have the functional group aldehyde will be the carbon 1. So that is how we name a aldehyde. And for the ketones, we have again 2 different scenarios. The first one is acyclic ketones. For example, now we are going to have 5 carbons, 1, 2, 3, 4, 5 carbons right here. And on carbon 2 from the right, I have a carbon-oxygen double bond because we are looking at this functional group here. One side you have this propyl group, the other side have methyl group, so you have 2 alkyl groups. So this is the ketone. So for the ketone, the first thing is for the acyclic ketone, we want to see how long is a carbon chain that include the sp2 carbon, which belong to the carbonyl carbon. So which is this carbon right here. And for this carbon, in the carbon chain, what we have here is 5 carbons, and we want to give that carbon-oxygen double bond carbon the lowest locant possible. So that is why we number the parent chain longest carbon chain, include that sp2 carbon from the right side. So now my carbon-oxygen double bond land on the carbon 2. And that basically tell you where is this carbon oxygen double bond. The functional group is ketone. So what we are going to do here is we are going to first, as the aldehydes, now we are going to drop the N E and change it to ketone on. So on is not 1, it's on. So when you have 5 carbons, 1, 2, 3, 4, 5, this is your pentane. Now basically we are going to drop that E. We will have pentanone. Okay, so pentanone. So that is how we drop to give the ketone name. Now the next thing is we want audience to know where is this carbon oxygen double bond. That tells you it's 2 because it's at carbon 2. So that is 2-pentanone will tell you where is carbon oxygen double bond plus how many carbons in the parent chain, and plus it's on, so it is a ketone. And a lot of time you also will see people write as penta and then 2 on, also the same way. That indicates the carbon oxygen double bond is on the carbon 2. So that is when you have acyclic ketones. And what if you have this carbon oxygen double bond on the ring, that one of this sp2 carbon is on the ring? So this is cyclic ketones. So for cyclic ketones, we are going to just follow the rule to drop off the E. So if you have a cyclohexane, this is called cyclohexane. Now, if you get a ketone, we are going to drop E to the on. So this one called cyclohexane. No. Okay, so that will tell you where what type of ketone this will be. And for the numbering of the ring, just in case you do have substitute this ketone, because that apparent this ketone carbon always get the first. So that is AUPAC naming. And for the AUPAC naming, another thing now is we have learned a lot of functional groups. So what if on a molecule that have more than just one functional group, what are we going to do? The next what we are going to talk about is the priority of functional group. For example, what we are going to look at is this molecule right here. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. And what we have here is a hydrogen, and you have double bond on this carbon, and then on this carbon you have a methyl group and also a OH group. So if you are simply looking at this molecule, on one side this is a aldehyde functional group CHO, and on the other side you have this OH group, which is a functional group for alcohol. So are we going to call this molecule a alcohol OL or a aldehyde AL? No. So that is going to be determined by the priority of the functional group. So priority of functional groups. So in general, if you have a amine group, so amine group you have the nitrogen with either hydrogen or alkyl group, so that will be the first one, and then that the lowest priority in amine is lower compared to OH group, which is alcohol OH group, and will be lower than the next one is a ketone. So if you have OH and ketone, alcohol and ketone will be more prioritized, and then followed by a aldehyde, and then followed by the ester, and the highest priority is your carboxylic acid. So if you have a carboxylic acid group, then that parent chain will be carboxylic acid. So the priority goes down. I realize I spelled something wrong. So priority, okay, priority. And what does that mean? So if we are looking at our molecule right here, we have a alcohol right here and aldehyde right here. If we refer to our priority of functional group, aldehyde is higher prioritized than the alcohol. So our main parent chain will be a aldehyde. Now we are going to follow the IUPAC naming to name this parent chain first. So this is our carbon 1, 2, 3, 4, 5, 6, 7. So for parent chain, we do have 7 carbons. So that will give us a heptanol. Okay, heptanol. Okay, Al at the end. And then we are going to follow the IUPAC naming rule that to indicate any stereochemistry on this molecule. So what we see here is this carbon 5, which is a chiral center. So we are going to determine what is absolute configuration. So for this one, OH gets first, and then this isopropyl group gets second, and third and fourth. So if we count 1, 2, 3, it's counterclockwise. However, fourth group is pointing towards you, meaning this is R. So what we have here is R as the stereochemistry for this molecule. And then we are going to list all the other substituents. So for substituent, we do have a methyl group on 5 and a methyl group on 6. So we have 5,6 dimethyl. And we also have a OH group. Now it's just as a substituent, so it's hydroxy. So we will have hydroxy group on carbon 5, 5 hydroxy. And then we have 5 and 6. We have dimethyl. That is substituent, and to complete what is the name of this molecule. So it's based on the priority of the functional group to give the parent chain the name. And another thing we want to talk about here is when we have a unsaturated ketones. For example, we already see the alpha beta unsaturated ketone. How to name it? For example, what we have here is this molecule right here. And we notice on this molecule, we have a carbon-oxygen double bond and carbon-carbon double bond. So when you have carbon-carbon double bond, that is alkene, and carbon-oxygen double bond with 2 R group, that is a ketone. So it is unsaturated ketone. So how to name it? First of all, ketone is higher prioritized compared to the alkene. So we can now call it alkene. It's a ketone. And because it's unsaturated, we will incorporate the alkene part into the naming. So before we have pentane, T-A-N, now we have pentane, T-E-N. So we are going to put those two together. And now we are going to count how many carbon. Again, we want to give the ketone the lowest locant possible. So that is why we number from right to the left. And on carbon 2, we have the carbon-oxygen double bond. So now we have pentane to indicate that is a unsaturated ketone, and pentanol will give you the idea this is unsaturated ketone. Now where is the ketone? Now we are going to insert, okay, this part, pentane. This tell you the alkene, this tell you it is a ketone. So we are going to insert to tell the audience where they are. So first of all, we have the in part at carbon 3, so pentane, and then 2 where the ketone starts, so 2 no. And also, what we want to include here is stereochemistry, because we have this alkene. And for this specific one is the E configuration. So we are going to put the E in the front. So that is how we name unsaturated ketone. The last thing about the naming of ketone and aldehyde is it's just a few common names that you do need to know. Common names. For example, for the aldehyde, if we have both sides of this sp2 carbon have hydrogen, we call it a formaldehyde. So formal is this part right here. This group right here is formed to indicate it's carbon oxygen double bond with a hydrogen, formaldehyde. And if we have the next one, is this one right here, it's called acid aldehyde. So again, what we have here, this group is called acetal. Okay, so ACET. So if you remember, we have this acid called acetic, right? So this indicates this group right here. So acetic acid, this is acetic acid. That is a common name for this acid. So acetic group. Okay, I put the O here. Acid group. Okay, so the next one is when you have this benzene ring next to it, and benzene ring is benz, so it's BENZ, benzaldehyde. Okay, and that's it, plenty for the ketones. If we have one side is a relative simple methyl group, the other side is ethyl group, what we can do is called ethyl methyl ketone. So that is a common way that we can name it as well. So in our pack naming, this is 2-butanol and butanol. So we can also call it ethyl methyl ketone. And for the next one is this is called acetone. So ONE tell you that the ketone acid tell you the group that is a methyl group next to that sp2 carbon. And then if we have another one, this one right here, so we have a benzyl group and a phenol. If you are looking at this part right here, this is a phenol because you have phenol group, and we call it acetophenol. Okay, acetophenol, common names. And the last one is now we swap that methyl group to a phenol group, and it is benzene, so benzophenol. So again, the phenol part is this part right here. So you have a ketone that have this part. This is phenol, and depending on the R, you can give you either acetal or benzophenol. So that is how we can name aldehyde and ketones. These are some common names. That is the end of this video.